Welcome back to Chapter 6 of America's Boating Club's Sail Course. In this chapter, we will be covering running rigging. Running rigging is essentially the things that we can adjust when we're out sailing. Running rigging consists of the main sheet block, traveler car, halyards, main sheet, Cunningham, boom vang, gooseneck, jib downhaul, topping lift, whisker pole, and Spinnaker pole, as well as how. This is an illustration of a small cabin boat, like what you would see over on Clinton Lake or in central Illinois. They have many of the systems that we need. Okay, so for example, in this case, here's our main sheet system, which controls the main. We've got our Outhaul, which pulls out the foot of the sail. Our Cunningham pulls down the front of the sail. We've got jib sheet. This would be our jib sheet. Sheets are ropes that control the sails in and out. Here's where the halyard is controlled on larger boats at the mast. The halyards are the ropes, the lines that raise the sail up, hold the sail up. Halyards can be, steel cable as well as cable spliced to a rope to make it easier to handle. The halyards tend to be high-performance lines that have limited stretch. These would be like Kevlar, Technora, Dyneema. Those are some of the brands that people are currently using. The reason they're using this high-tech stuff is it's very low stretch and lightweight. However, to get those advantages, they're also much more expensive. Here's the boom vang on this boat, and it's essentially a block and tackle system that holds the boom down when we're underway. Here's a close-up diagram of the boom vang system on a boat. It essentially is a block and tackle system that runs from the base of the mast down out to the boom. It's got, sometimes they have cleats on them, and sometimes they are led to cleats on the deck. The value of the boom vang is it holds the sail boom down while we're sailing downwind. And it also, when we're reaching, we're adjust the mainsail twist. We'll cover that a lot more in later chapters. So what happens is we can reduce the twist and the leach of the main by pulling down on the boom, and that tightens up the leach. If we didn't have the boom vang, as we let the sail out with our main sheet, as soon as the boom gets past the stern quarter, the main sheet no longer pulls it down. And so then we need to use the boom vang to hold the boom in the proper place. On most of the boats sailing in our area, we use the block and tackle system for the boom vang. On bigger boats, they often have a stiff pole that may have internal blocks or maybe outside. And this stiff boom vang could be hydraulic. It could be hydraulic too, and it can hold the boom down. But a hard boom vang also can hold the boom up in very light sailing conditions. Here's a diagram of a traveler system that we find on many boats. This one is really just like the traveler system on my Capri. What it does is allows a car to slide a track that goes from side to side. The track goes from side to side, and then it has a car that slides on that track and then can be moved with a block and tackle system, upwind or downwind. This enables us to move the main sheet when there are very high loads on it. The main sheet controls the leach tension. The traveler controls how far the boom goes in and out, which affects our angle of attack of the mainsail. Some traveler systems permit windward sheeting, which enables us to pull the boom up to the center line of the boat. Here's a diagram of the way a Cunningham works. This one is a Cunningham that's on the jib. The mainsail also may have a Cunningham. What it does, the Cunningham adjusts the maximum draft position of the sail. And generally what we do is we trim the sail until the wrinkles in this part of the sail just become barely visible. The more we pull down on the Cunningham, the farther the draft is going to be moved forward. We also may need to put more Cunningham on when the wind increases. Generally, it's the last item that I trim when I'm setting up my boat. This illustration shows the outhaul. In this case, what the outhaul does is it pulls the foot of the sail out to the end of the boom. And what we can do is it tightens the foot, and what it does is it reduces the draft or the power that the lower half of the sail has. This also shows an example, the tabling that the sail has to make it more strength. Each one of these is a layer of sailcloth that has been built into the sail to provide extra strength. Here we see the gooseneck, the gooseneck, and the gooseneck is the fitting that attaches the boom to the mast, and it has a swivel or some way of allowing it to move around in all kinds of directions as we adjust the boom position. On many boats like our lasers and thistles and Scots, the gooseneck is fixed to the mast in a specific place. On some boats like my Capri, the gooseneck is actually on a track or slides up and down, so we can adjust that a little bit. So if we need to tighten the luff of our sail, we can, if the gooseneck moves, we can pull down on that using the downhaul. The downhaul is essentially a line that pulls down on a sail or spar. If, like Scots and thistles, if the gooseneck is fixed, the downhaul would actually then attach to a grommet on the sail. Here's an example of a topping lift that's used on larger boats. What this does is the topping lift then provides an ability to hold the boom up when there isn't anything else supporting it. Most of the time when we're underway, the back end of the sail will hold the boom up so that it will support it. But when we drop the mainsail down, the boom then would typically drop down to the deck and then get in our way when we're trying to put things away. In addition to the line going to the top of the bass, on my Capri, the topping lift actually attaches to the back of the backstay and to hold it up from there. Another method for controlling or holding the boom up when we're lowering our sails is a method of lazy jacks. And what a lazy jack system does is it's a set of lines here that attach to the boom, and then we can use it to hold the boom up when we drop the sails. Another thing that's nice about the lazy jack system is it controls and keeps the sails inside the lazy jack area as we drop them down. Another system similar to this is called the Dutchman, where instead of using these big lines, they actually use monofilament lines that go through the sail to guide it down on the boom, and it helps it fold in an orderly manner. If we had, in this example, we also have full battens. This is a fully battened main, so the battens go from the back of the sail to the front and attach to a car, and so that brings the sail down in a nice orderly fashion. Some boats are equipped with a Spinnaker. This is a downwind sail that I consider to be high risk, high reward, because it really puts a lot extra sailcloth up on your boat when you're going downwind. The reason it's high risk is if you look at all these lines, there's lots of stuff that has to go right and not get tangled when you're trying to fly it. So let's look at some of the things that we've got going on to make the Spinnaker work. I guess the first thing we got to look at is our Spinnaker halyard. That's going to raise the Spinnaker up to the top of the mast. We've got control lines, like a jib and main sheet have sheets. Well, the Spinnaker has a sheet that goes to the back of the boat that's used for trimming. In addition, we've got the other side of the foot of the sail is attached to a guy. The guy goes to the back of the sail, and that adjusts where the Spinnaker pole is, fore and aft adjustment for the Spinnaker pole. Now, on boats, the Spinnaker pole is quite heavy, so if it were not supported, it would drag down the corner of the sail. So we have a topping lift to hold the pole up while it's underway and takes the pressure off from the Spinnaker. But if the wind gets really crazy, and I'll show some pictures of Spinnakers getting out of control sometime, that the Spinnaker pole can actually then fly up in the air and let the Spinnaker get out of control. So in order to keep it from the Spinnaker pole from rising, we've got the Spinnaker pole fore guy. Now in my boat, we don't talk about fore guy, we talk about pole downhaul. Essentially, it pulls down on the pole to keep it under control. Here's an example of an arrangement for boats that don't have Spinnakers, and they can use this one going downwind. And instead of this, they would have, instead of a Spinnaker pole, they have what we call a whisker pole. Now the difference between the two is a whisker pole is generally longer and lighter and attaches directly to the jib. So we don't have a different sail, we just have a way of holding the jib on the outside of the boat. Now, typically when you would see this is when we're going downwind, and the maneuver is called wing and wing. We have the main sheet out on one side of the boat, in this case it would be on the port side of the boat, and this jib, the front sail, would be on the starboard side of the boat. And so you're projecting a lot more sail as you go downwind. In order to make this work, you're really using the same controls. The jib sheets control the shape of the position of the sail. And if the Spinnaker pole is very heavy, you may have a topping lift. But on most of the boats I've been on, they don't have a topping lift. The lift is really provided by the sail itself. As we've already covered, we've got a lot of control lines and things that are helping us manage the sails as we're underway. And to make our life easier, we have things that we call cleats. And there's some examples of cleats, and then also blocks that can give us and help us with get mechanical advantage. Blocks are essentially used to change the direction of a pull or a force. They're just another name for a pulley. A block is a pulley. We can also arrange multiple blocks in systems that then provide a mechanical advantage for us. In addition, more expensive blocks actually have a ratchet mechanism built into them to help hold the line and take some of the force off our hands as we're pulling on them. Now we're going to look at some of the cleats that help us hold a line after we've reached an adjustment point. And this example is a cam cleat. And here we've got, this is essentially the cam that works in pair to hold the line together. So there's a spring on the cam that causes it to snap shut, and then we just pull the line through the cams and then it holds it in place. Some better cleats actually have a rounded area here that makes it easier for the line to slide in. Sometimes if these cleats are under very heavy load, they may be hard to uncleat. And so we have to kind of figure that, allow for that as we're building our systems. Here's an example of a clam cleat. If you look at the edges of this cleat, they've got, it looks like the mouth of a clam on both sides of this of the cleat. And what it does is you push the line down in there, and then that's what grips on the line. Unfortunately, and some of you may have experienced this when down at Clinton Lake on some of our lasers, we have a lot of clam cleats on lasers, and as they get worn, they can come uncleated unexpectedly. So that's one of the downsides to the clam. Here's another high-tech approach for cleating a line. And this is called a line stopper or rope clutch. And in this case, it's a clamp that comes down on the internally. There's a cam inside the box that's pushed by this lever. And what it does is it clamps down on the line as it pulls through. And one of the nice parts about a rope clutch is that it can be released very quickly, and it can be released when under high loads. So you'll see these clutches on bigger boats where the loads are hundreds or thousands of pounds on the line. And you can just pull the lever up, and then it becomes free to run. One of the applications of a clutch is to run a bunch of lines through to the deck, to a common deck point. Commonly, clutches then are also backed up with a winch, which we'll talk about in a minute, and then you can have multiple lines that are being able to be pulled by the same winch and controlled in the same time. Here's an illustration of a winch that's used to grind in or pull in the lines that are under load. We've got really two kinds of winches. We've got regular winch that's just simply wrap the line goes around the drum, and then you hold on to it. It requires a cleat to stay in place. We've got also have self-tailing winches, which is what this example has. In the self-tailing part, it doesn't require a cleat because the cleat is built into the top part here. It's some winches are single speed, where you just grind in one direction, or 2 or 3 speeds, which provides additional mechanical advantage on it. The mechanical advantage from a winch is essentially from the winch handle. These winch handles can be 8 or 10 inches long and stick into the top of the winch. The number on the winch really just identifies how much mechanical advantage that you're going to get by using that particular winch. The winches are usually used to handle very heavy loads, and the self-tailing winches have these jaws or plates on the top that grip the line as you grind it in. Winches are often used when they're very heavy loads, and it's a good practice if you were having a clutch come to this that was heavily loaded. You might put 1 or 2 wraps around the drum to just kind of help control ease the release of the line when you open the clutch. Here's how you use the winch in practice. Okay, you start by taking the line and wrapping it around the drum in a clockwise fashion. You pile the loops on the drum from the bottom to the top. The more turns you put on it, the heavier load it will absorb. Occasionally, you may see an overwrap, which is caused by part of the line to fall over the top of itself and then form a jam. So what I do, often overrides occur when too many wraps were taken at the start of the pull in. So what I recommend and almost require my crew when we're using the winch to control the jib sheet is to put 2 wraps on the drum, pull it in as fast and as hard as you can, and then when it starts slipping, put a 3rd wrap on around the top, and then grind it in the rest of the way. Here's an example of how lines and blocks and winches are grouped together to control the sails or other mechanical areas. So, in this system, we've got multiple line stoppers that go up and allow each one of those lines to be controlled by the same winch. We've got turning blocks here that change the direction. And in many cases, we've got double-sided systems so that it's easy to work from either side of the boat. What we're trying to do is run our lines so that they're in position for the crew to operate when they're in their station. We also want to have the lines so that when you're pulling on it, it's in a direction that is comfortable to pull. Let's run over our vocabulary for this chapter. Bitter end is the end of the line that's that's in the vessel, as opposed to the working end that's attached to an anchor or cleat or some other vessel. The reason it's called the bitter end is if you should come untied or lost, it kind of gives you a bitter feeling as the line drops in the water and goes away. We've talked about the boom vang, which controls holds the boom down as we change our sail trim. Cleat is a method for holding a line after we've put it in a proper adjustment. Downhaul is a line or tackle used to pull down on a spar or sail. A line stopper is simply a clutch that's a little higher tech that holds a line in place. Tackle is a group of multiple blocks and lines that increase our mechanical advantage. Then a traveler is the system that moves the main sheet in and out across the boat. And finally, a turning block is used to change the direction of the line or create a mechanical advantage. This completes section 6 on running rigging. Our next section will be on stability. Here's a short video from North that's somewhat a bit of a commercial, but also shows some of the technology that goes into creating a sail.
No matter where you are in the world, what body of water or what No matter where you are in the world, what body of water or what boat you're in, North Sails stands for perfection in sail technology and design. North Sails manufactures sails for virtually every type of sailboat on the planet. Sail shape, construction and choice of materials are the result of intensive design research and development, of which North Sails has been the undisputed industry leader for the past 2 decades. The design process starts by entering boat specifications and range of sailing conditions into the multi-process North Sails Design Suite software. The designer's first tool is the Desmond program that visualizes all combinations of sails and their geometry to establish the optimum fit to the boat and rig. The spiral program takes the optimum area and geometry established in Desmond and gives the sail 3-dimensional shape, providing the designers with precise control over all aspects of the sail. The flow program analyzes the performance and wind pressure of the spiral mold and all forces, including lift and drag, that are generated by the new sail shape. When analyzing the forces affecting a downwind sail, North Sails' one-of-a-kind virtual wind tunnel provides a unique insight into the flying sail's shape, stability and ease of trim. Membrane lets the designers visualize the sail's flying shape, the varying load on the sail, and therefore the load on the rig and boat. The Velocity Prediction program uses information from all the other programs to define and analyze the performance of the boat with a wide assortment of sail shapes and combinations in a variety of conditions. The North Sail's design process is at the pinnacle of the industry, but without the right people, it's only half the equation. The North Sail's design team consists of 65 of the world's top sail designers, working in concert with 5 full-time software engineers to continually push the boundaries of sail making. The designers share information and new techniques, creating an international network with unmatched depth, efficiency, and expertise. The design veterans of today continually educate the bright stars of tomorrow to ensure that the best people will always be found at North Sails. North Sails employs the best people, the best technology, and a 100% vertically integrated supply chain to manufacture sails that are quite simply better by design.
You may have noticed in some of the design when they were putting together the sailcloth and things like that, there were little, it was first of all a plastic sail with little threads running along the load points. And that's what those boys were really trying to decide. This stuff was cutting edge a few years ago, and it's been surpassed by even later developments in how to create better shapes, better computer models, to see what those shapes are and to go from there.